Given the line 3x minus 2y plus 12 is equal to 0 intersects the parabola 4y is equal to 3x square at the points A and B. Let us mark this point is A and here the point is B. Then at the vertex of the parabola, which is origin 0, 0 for the parabola x square is equal to 4ay, the line segment AB subtends an angle equal to. So let us consider an angle is here theta. At the vertex of the parabola. And since the line 3x minus 2y plus 12 is equal to 0, its x coordinate is minus 4, means x intercept is minus 4 and y intercept is 6. So you get the line, is the way. And now substituting y is equal to, put y is equal to 3x square by 4 in the line equation. So we get 3x minus 2 times of 3x square by 4 plus 12 is equal to 0. So we can write 12x minus 2 3 the 6x square plus 12 4s are 48 is equal to 0. Or you can take even 3 common, or 3 into 2 6 common. 2x minus x square plus 8 is equal to 0. Or we can say x square minus 2x minus 8 is equal to 0. So by simplifying, x square minus 4x plus 2x minus 8 is equal to 0. X times of x minus 4 minus 2 times of x minus 4 is equal to 0. So x minus 4 into x minus 2, which is equal to 0. So plus 2. So we can say x is equal to 4 and x is equal to minus 2. So at x is equal to 4, when x is equal to 4, y is equal to 3 into 4 square divided by 4, that is y is equal to 3 into 4, 12. That is 4 comma 12 is 1 point. And another point when x is equal to minus 2. So y is equal to 3 into minus 2 whole square, that is 4 upon 4, which is equal to 3. So minus 2 comma 3 is another point. So let us consider A is the point minus 2 comma 3 and B is the point 4 comma 12. Let's find the slope of OA. So we can write slope of the line segment OA, which is equal to, we know the formula, slope is y2 minus y1 by x2 minus x1. So we can write 0 minus 3 divided by 0 minus of minus 2, that is minus 3 by 2. Say this is m1. And similarly, slope of OB, which is equal to 0 minus 12 divided by 0 minus 4, that is 12 upon 4 minus 12 by 4 minus 4, which is equal to 3. Say this is m2. And we know that if theta is an angle between the lines OA and OB, then we have tan theta is equal to mod of m1 minus m2 divided by 1 plus m1 m2. So let us substitute here. So tan theta is equal to mod of minus 3 by 2 minus 3 divided by 1 plus of minus 3 by 2 into 3. On simplifying, you will get minus 9 by 2 divided by, so 2 minus 9 that is minus 7 by 2. So tan theta is equal to, we can write 9 upon 7. So theta is equal to tan inverse of 9 by 7. So which is our option B. So you can go with an option B. Given the area of triangle PQR with vertices P5, 4 and Q minus 2, 4 and R A, B with 35 square units, and if its orthocenter and centroid is given 2, 14 by 5 and C, D respectively, then we need to find C plus 2D. Since orthocenter is given, we know that orthocenter is the point of concurrence of the altitudes. So here we can say PM is perpendicular to QR and also QN is perpendicular to PR. So let us find the slope of PO. Slope of OP is equal to, we know the formula for slope, y2 minus y1 by x2 minus x1. So here we can write 14 upon 5 minus 4 divided by 2 minus 5. So we can write 14 minus 20, that is minus 6 divided by 5 divided by minus 3, or we can write 6 upon 5 into 1 upon 3, which is equal to 2 by 5. So slope of OP is 2 by 5. So we can also say slope of PM is 2 by 5. And next the slope of OQ. Slope of OQ is equal to 14 upon 5 minus 4 divided by 2 minus of minus 2. So which is equal to minus 6 by 5 divided by 4. That is minus 6 by 5 into 1 by 4. That is minus 3 by 10. Slope of OQ is equal to minus 3 by 10. So which also implies here slope of QN is equal to minus 3 by 10. And we know the relation when the two lines are perpendicular, m1 m2 is equal to minus 1. So we can say slope of QR is equal to, or slope of QR into slope of PM is equal to minus 1. So slope of QR is equal to minus 1 by slope of PM. That is slope of PM is nothing but slope of PO, that is 2 by 5. So we can take minus 5 by 2. Similarly, slope of the line segment QN into slope of the line PR, which is equal to minus 1. So slope of QN is minus 3 by 10 into slope of PR minus 1. So we can write slope of PR is equal to minus 1 divided by minus 3 by 10, that is 10 upon 3. Since we know the slope of QR, you can find the equation of the line passing through the point Q 2, minus 4. So by using the formula, y minus y1 is equal to m into x minus x1. So we can find the equations of the lines QR and PR. Now let's find the equation of QR. So we can write y minus y1 is equal to, the slope of QR is minus 5 by 2 into x minus of minus 2, that is x plus 2. So simplifying, we can write 2y minus 8 is equal to negative 5x negative 10. So which implies that 5x minus 2y, and minus 10 plus 8 is minus 2 is equal to 0. Sorry, 5x plus 2y plus 2 is equal to 0. So it's an equation 1. And now the equation of the line PR, we can say y minus y1 is equal to the slope of the line is 10 by 3 into x minus 5. So which implies 3y minus 12 is equal to 10x minus 50, that is 10x minus 3y, and here minus 50 plus 18 plus 12, which comes minus 38. The second equation. So solving 1 and 2, so we can say we can write x upon, so here minus 76 plus 6, which is equal to y upon, so 20, and again here plus 190, which is equal to 1 upon minus 15 minus 20. So x is equal to minus 70 divided by, which is equal to minus 1 by 35. So minus 35, which is equal to 2. Similarly, y is equal to, so 190 plus 20 is 210. 210 divided by minus 35, which is equal to, we'll get 6, minus 6. So therefore, we got the point R A comma B is equal to 2 comma minus 6. And now the centroid. Centroid is x1 plus x2 plus x3 by 3, y1 plus y2 plus y3 divided by 3. So here the three vertices, so you can take 5 plus of minus 2 plus a value is 2 divided by 3, and here 4 plus 4 minus 6 divided by 3. So we have 5 by 3 comma 8 minus 6, 2 by 3, and which is given as C comma D. So we can write, so therefore C is equal to 5 by 3, D is equal to 2 by 3, and we need to find C plus 2 times of D, that is 5 by 3 plus 2 times of 2 by 3, which is equal to 5 upon 3 plus 4 by 3, which is 9 upon 3, which is equal to 3. So 3 is the answer, which is our option 2. We need to find the value of sine 70 degrees times cot 10 degrees cot 70 degrees minus 1. Let us simplify this. Sine 70 degrees into cot 10 degrees into cot 70 degrees minus sine 70 degrees. So we can write sine 70 degrees into cot is nothing but cos by sine, so cos 10 degrees by sine 10 degrees into cos 70 degrees divided by sine 70 degrees minus sine 70 degrees divided by 1. So here we can cancel sine 70 degrees, and by taking LCM, so we can write cos 10 degrees into cos 70 degrees minus sine 70 degrees into sine 10 degrees divided by sine 10 degrees. So numerator is in the form cos A cos B minus sin A sin B. which is equal to cos A plus B. So here we can write cos of 10 degrees plus 70 degrees divided by sin 10 degrees, which is equal to cos 80 degrees divided by sin 10 degrees. So and 80 and 10 are complementary angles. So we can write cos 80 as cos 90 minus 10 divided by sin 10 degrees. Cos 90 minus theta is sin theta, that is sin 10 degrees divided by sin 10 degrees. So we get the answer as 1. So option 4 is the answer. Given that marks obtained by all the students of class 12 are presented in a frequency distribution with the classes of equal width, let the median of this group data be 14 and the median class is 12 to 18 and the median class frequency is 12 and the number of students whose marks are less than 12 is 18. So then the total number of students is. So in the median class is given 12 to 18. So that the frequency is given and its frequency is given as 12, and also the number of students whose marks are less than 12 is 18, means cumulative frequency preceding to the median class it is 12, 18, and we need to find the total number of students. So here we can say that the length of the class interval, that is h, is equal to upper limit minus lower limit. So that is 18 minus 12 is 6 and small f is equal to 12 and cumulative frequency, that is capital F, is equal to 18 and L is equal to the lower boundary or lower limit, that is 12. So here 12 is the lower limit. So we have the median formula for frequency distribution, L plus n by 2 minus f divided by small f into h, where capital F is the cumulative frequency that is preceding to the median class and small f is the frequency of the median class. And h is the length of interval and L is the lower limit or lower boundary of the median class. So let us substitute in the formula. So we have median m is equal to L, that is 12, plus n by 2. We don't know the total number, so let us put n only, minus capital F, that is 18, divided by small f is 12 into the height is 6. Height is nothing but length. And also given the median is given as 14. So 14 is equal to, and here 6 2 times, so we can add 12 plus n by 2 minus 18 into 1 by 2. So 14 minus 12 is 2 and here n by 2 minus 18 and it's multiplied with 2 will come here, so 4. So we can write 4 is equal to n by 2 minus 18, or we can write n by 2 is equal to 8 plus 4 22. So n is equal to 22 into 2, that is 44. So we can say that the total number of students is 44 in this case. So which is option C. Given that the first term of an AP, say A is equal to 3, and the sum of its first four terms S4 is equal to 1/5 of sum of the next four terms. Next four terms is up to 8 terms, that is S8 minus S4. And then the sum of the first 20 terms is we need to find. Let us consider T is the common difference. So that we can have sum of first four terms. S4 is equal to 4 by 2 times of first term, that is A, and the last term, that is the fourth term, that is A plus 3D, that is 2 times of 2A plus 3D. And similarly sum of next four terms, we can consider, that is 4 by 2 times of the first term will be the fifth term and the last term will be the eighth term, which is equal to, since we know the formula, Sn is equal to n by 2 times of first term plus last term. So here we can write 2 times A5 is nothing but A plus 4D, because we know that nth term in arithmetic progression is A plus n minus 1 of D. And here eighth term we can write A plus 7D, that is 2 times of 2A plus 11D. Since both are equal, 2 times of 2A plus 3D and 2 times of 2A plus 11D. So we can write 2 times of 2A plus 3D is equal to 2 times of 2A plus 11D, which implies 2A plus, or 1/5, sorry, 2 by 5 times of. So we can cancel here 2. So we can write 2A plus 3D 5 times, which is equal to 2A plus 11D. That is 10 times of A plus 15 times of D is equal to 2A plus 11D, or 10A minus 2A, that is 8A is equal to 11 minus 15, that is minus 4D. Or we can write, since A is equal to first term is 3, so 8 3s are 24 is equal to minus 4D, or D is equal to minus 6. So we got the value of D, common difference is 6, negative 6. Now we need to find the sum of first 20 terms, that is S20 is equal to n by 2, that is 20 by 2. First term is A and last term is 20th term. 20th term is equal to A plus 19D, that is 3 plus 19 times of minus 6, that is 3 minus 114, that is minus 111. So A plus A20, which is equal to 10 times of 3 minus 111, which is nothing but 3 minus 111 is minus 108, which is equal to minus 1080. So minus 1080, which is option C, option 3. The number of words which can be formed using all the letters of the word daughter, so that all the vowels never come together. So in the word daughter, so we can see that the vowels are A, E, U. So there are 3 vowels, and the condition is that these 3 vowels never come together. So let us consider its complementary case. When all the 3 vowels come together, in how many ways we can arrange? So let us put all the three vowels together, A, E, U, so that the remaining letters we can write D, G, H, T, R. So that we have 1, 2, 3, 4, 5, 6. So total we can fix like 6 boxes are there, and these 6 boxes we can arrange in 6 factorial, and again internally these 3 letters vowels can be arranged in 3 factorial. So 6 factorial into 3 factorial, which is the number of words can be found all the vowels together. But the question is all the vowels never come together, so we have to consider the complementary case. So without any condition, the total number of arrangements of the word daughter can be done as, since there are 1, 2, 3, 4, 5, 6, 7, 8. 8 letters are there, all are different letters, so we can arrange in 8 factorial. So this is the total number of possible words without any condition. So that we have to take the complementary, that is minus. So the required answer is, that is vowels never together, never come together, which is equal to all possibilities without any condition minus all vowels, 3 vowels come together. So here all possibilities are nothing but 8 factorial minus all the 3 vowels come together is 6 factorial into 3 factorial. So here we can write 8 factorial, we can write it as 8 into 7 into 6 factorial minus 6 factorial into 3 factorial. So 6 factorial is taken common, 7 8s are 56 minus 3 factorial is 6. So 6 factorial is 720 into 56 minus 6 is 50. So 72 5 times. So we can write 3000, 36,000 we can give the answer. 36,000, which is option C. Given that modulus of z bar minus I upon 2 times of z bar plus I is equal to 1 by 3, where z is a complex number, be the equation of a circle with a center at C if the area of the triangle whose vertices are given 0, 0, C and alpha, 0 is 11 square units, then we need to find the value of alpha square. So let us consider complex number z is equal to x plus iy, so that we can write z bar is equal to x minus iy and z bar minus I, which is equal to x minus iy minus I, that is x minus y plus 1 of I, and also 2 times of z bar plus I we can write 2 times of x minus iy plus I, that is 2x, and again plus of minus 2y plus 1 of I. Let's consider mod of z bar minus I divided by 2 times of z bar plus I, which is equal to 1 upon 3. So we can write, since we know that mod of z1 by z2, which is equal to mod z1 divided by mod z2, where z1 and z2 are two complex numbers where z2 not equals to 0. So here we can write mod of z bar minus I divided by mod of 2z bar plus I, which is equal to 1 upon 3. And also if z is equal to x plus iy, then we have mod z is equal to under root of x square plus y square, and mod z square is equal to x square plus y square. So let's do squaring on both the sides. So we can write mod z bar minus I whole square divided by mod of 2z bar plus I whole square is equal to 1 upon 9. So we can write here mod of z bar minus I is x minus of y plus 1, that is x square plus of minus of y plus 1 whole square, or y plus 1 whole square same. So y plus 1 whole square divided by, here we can write 2x whole square plus of 1 minus 2y whole square, which is equal to 1 upon 9, or 9 times of x square plus y plus 1 whole square is y square plus 2y plus 1, which is equal to 4x square plus 1 plus 4y square minus 4y. So here 9x square minus 4x square, that is 5x square, and 9y square minus 4y square, that is 5 times y square, and here 19 times of 9 times 2 18y, and again plus, that is 22y, and again 9 minus 1, that is plus 8 is equal to 0. So this can also be written 5 taken common, x square plus y square plus 22, that is 2 into 11 by 5 times y plus 8 is equal to 0, which is an equation of circle. It's a circle with a center minus 11 by 5 comma, sorry 0 comma minus 11 by 5. When it is compared, x square plus y square plus 2gx plus 2fy plus c equals to 0, the center will be minus g comma minus f. So here coefficient of y is there, coefficient of x is 0, so 0 comma minus 11 by 5 is the center. Now we consider area of triangle. Since the vertices given points 0 comma 0, let us consider O, and C is the center, and alpha comma 0, so let us consider this is P. It's a triangle so we can see that OCP is a right angle triangle, clearly right angle at O, and its area is given total 11 square units. So its area is equal to half into, so we can consider this as alpha mod alpha into, and here this area, this length is minus 11 upon 5 units, which is equal to 11 square units. So we can also write half mod alpha, and mod of negative 11 by 5 you can take plus 11 by 5, so which is equal to 11 into 5 by 11, or mod alpha is equal to 5 to the 10. When mod alpha is equal to 10, alpha is equal to plus or minus 10, then alpha square can be taken as plus or minus 10 whole square will be 100. So alpha square value will give 100, which is option B. Option B is the answer. We need to find the sum of all rational terms in the expansion of 1 plus 2 to the power 1 by 3 plus 3 to the power 1 by 2 whole power 6. So we know the general term in the expansion of x plus y plus z whole power n, it's a multinomial theorem, is n factorial upon alpha factorial, beta factorial, gamma factorial into x power alpha, y power beta and z power gamma, whereas the sum alpha plus beta plus gamma must be equal to n. So here we can write 6 factorial general term, alpha factorial, beta factorial, gamma factorial into 1 to the power of alpha, 2 to the power 1 by 3 whole power beta, and 3 to the power 1 by 2 whole to the power gamma. So since we need to get the rational term, so here 2 power 1 by 3 whole power beta, so beta must be So we can write beta must be either 0 or multiple of 3. It's 0, 3 and 6. So these are the possibilities of beta we can consider. And here gamma can be taken as, to get the rational terms, it's a multiple of 2, either 0 or 2 or 4. 0, 2 and 4 are the three possible values. And even we can take gamma is equal to 6 also. Right. And alpha can be taken any value. So let us consider the table. Alpha, beta and gamma, so that if we consider beta is equal to 0, beta is equal to 0 and alpha also 0, then gamma can be taken as 6, because alpha plus beta plus gamma must be equal to 6. And also if beta is equal to 0 and if consider alpha is equal to 2, so beta gamma can be taken as 4. So 2 comma 0 comma 4. And also if beta is equal to 0, if gamma is equal to, or gamma is equal to here 2, so here alpha can be taken as 402. And again if beta is 0, if gamma is also 0, then alpha can be taken as 6. So these are the 4 different possibilities when beta is equal to 0. And similarly when beta is equal to 3, so we can write, say gamma is equal to 6 is not possible, 4 is also not possible. If gamma is equal to 2, so 3, 2, and here we can say alpha is equal to 1. Again beta is equal to 3. If gamma is equal to, next case is 0, then alpha can be taken as 3. So only 2 possibilities with the 3. And next again with the, if beta is equal to, the next possibility 6, then we can take gamma 6 is not possible, 4 not possible, 2 is also not possible because the sum is exceeding 6, so only 0 is the possible. And here also alpha also 0. So this is only one possibilities. So let us consider the terms in each case. So we can write the first term 6 factorial upon alpha factorial, that is 0 factorial, 0 factorial, 6 factorial into 1 to the power of alpha, that is 1 power 0, and 2 to the power of 1 by 3 whole power 0 is 1, and 3 power 1 by 2 whole power 6 is nothing but 3 power 3, that is 27. 6 factorial upon 6 factorial is 1, so 27 is the first term. And similarly second term, so we can write 6 factorial divided by 2 factorial and 4 factorial into 1 power alpha, there is 1 anyhow, and 2 power 1 by 3 whole power, there is also 1, and 3 power 1 by 2 whole power 4 is 3 square, which is 9. So 6 factorial upon, so we can write this as 15. 6 factorial upon 2 factorial into 4 factorial gives 15. So 15 into 3 square, 15 nines are 135. So 135 is the second term. And similarly the next one, so this is 6. So the next term is 6 factorial upon, again 4 factorial, 2 factorial into, again 1, and gamma is 2, so we can add 3. So again this is 15 into 3, 45. So 45 is another term. And coming to the next one, 6 factorial upon 6 factorial, and again here 1 into 1, and again 3 power 0 is again 3 power 1 by 2 whole power 0 gives 1, 1. So we can say this is 1. So another term is only 1. And next term 6 factorial by 1 factorial, 3 factorial, 2 factorial. So we can write this is value 60 factorial simplification, and here 2 power 1 by 3 whole power 3 is, that is nothing but 2, 2 power 1 into again 3 power 1 by 2 whole power 2 is 3. So 60 into 2 into 3 will get 360. 6 factorial upon the next one, which is 3 factorial into 3 factorial into, so here 1 into, and here 3, that is a 2 into 3 to the power of 0, which is 1. So we can write 6 factorial upon 3 factorial to 3 factorial will give 20. 20 into 2 is equal to 40. And the last one, 6 factorial upon 6 factorial into 1 into 2 power 1 by 3 whole power 6, that is 2 square, that is 4, into again 1. So 6 factorial by 6 factorial is 1 into 4, which is 4. Now sum of all the rational terms. Sum of all rational terms in the expansion, we can say 27 plus 135 plus 45 plus 1 plus 360 plus 40 plus 4, which is equal to 612. So 612 is the answer, which is option. It's a numerical. We can write the answer 612. Given a quadratic equation, a times of b minus c of x square plus b times of c minus a of x plus c times of a minus b is equal to 0 has equal roots, and also a plus c is equal to 15 and b is equal to 36 upon 5, then we need to find a square plus c square. So clearly we can say that this quadratic equation is a cyclic whose coefficients are in cyclic order. The sum of the coefficients, that is a times of b minus c plus b times of c minus a plus c times of a minus b is equal to 0. Since we know that if a quadratic equation ax square plus bx plus c is equal to 0, whose sum of the coefficients, that is a plus b plus c is equal to 0, then the roots can be taken as 1 and c by a. So here we can say that 1 is the root and another root is c upon a. And also they said that it is equal roots. So 1 is equal to c by a, that is a is equal to c. So here we can say the coefficient of x square and constant both are same. So a times of b minus c, which is equal to c times of a minus b. That is ab minus ac is equal to ac minus bc. Or we can also write ab plus bc is equal to 2 times of ac. Or b taken common, a plus c is equal to 2 times of ac, and the b value is given 36 upon 5 and a plus c is given 15. So 15 into 36 by 5, which is equal to 2 times of ac, that is 2 times of ac is equal to 108 and ac is equal to 54. So we got the value of ac, and to find a square plus c square, so let us consider a square plus c square is equal to a plus c whole square minus 2 times of ac, that is 15 square minus 2 times of 54, that is 225 minus 108. So 225 minus 108 is 117. So we can say the answer 117. It's a numerical type. 117 is the answer. Let f of x is equal to log x to the base c and g of x a rational function. Then we need to find the domain of the function f circle g, that is composite function. Let us consider the numerator part of the g of x, that is x power 4 minus 2x power 3, and here 3x square I can split up into 3 terms, x square plus x square plus x square, and minus 2x, and again 2 I can split up as 1 plus 1, so that I can regroup the terms x power 4 minus 2x power 3 plus x square, and again x square minus 2x plus 1, and the remaining terms are x square plus 1. So here I can take x square common, so that I can write x square minus 2x plus 1, and again here x square minus 2x plus 1, which is x minus 1 whole square, and x square plus 1. So here the three terms are here x square of x minus 1 whole square we can write, or x minus 1 whole square plus x square plus 1. Clearly we can say that the first term x square into x minus 1 whole square is always greater than or equals to 0 for any real number. It can be equal to 0 also. And the second term, here we can say x minus 1 whole square the same way. For x is equal to 1, it will become equal to 0. So it can be greater than or equals to 0. And coming to the third term, x square plus 1, for any real number, x square plus 1 is always greater than 0. It cannot be equal to 0. So conclusion, we can say that the numerator part is greater than 0 of the function g of x. And now consider the denominator 2x square minus 2x plus 1. Let us find its nature of the roots. Comparing quadratic curve ax square plus bx plus c. Discriminant is b square minus 4ac. Let us consider. So minus 2 whole square minus 4 into 2 into 1, that is 4 minus 8, which is negative 4, less than 0. And hence we can say that there are no real roots, and since the coefficient of x square a is positive, so the curve will be open upward. So the curve 2x square minus 2x plus 1 is always positive. So we can say the denominator is also greater than 0. It cannot be equal to 0 also. So conclusion, the numerator, the g of x function, g of x, let us consider to be y, is equal to positive in the numerator and positive in the denominator. So we can say it is positive. G of x is equal to y positive. And also given f of x is equal to log x to the base e, and this function to be defined when x must be positive and the base e is anyhow greater than 0 and e is not equals to 1. So this function is defined for x is positive. And the composite function f circle g, let us consider f circle g of x. We can write it as f of g of x, which is equal to f of g of x as taken as y, which is positive value. F of y is equal to log y to the base e. And now this function is defined only for y is positive. But here we can say that y is positive for all real numbers. And hence we can say the domain of the function. So domain of the composite function f circle g is all real numbers. X belongs to R, which is option B. Given that one die has two faces marked 1, so let us consider D1, first die, two faces marked 1, that is 1 and 1, and two faces marked 2, 2 and 2, and one face is marked 3, and one face is marked 4. And the second die, we can say another die has one face marked 1, and two faces marked 2, and two faces marked 3, and one face is marked 4. So total 6 faces in each die. So here 6 numbers. And the probability of getting 1 in the first die is 2 out of 6, because total 6 elements are there. And probability of getting 1 is 2 out of 6. And probability of getting 3 is 1 out of 6. And probability of getting 4 is 1 out of 6. Similarly, the probability of getting the 1 in the second die is 1 out of 6. And probability of getting 2 is 2 out of 6. And probability of getting 3 is 2 out of 6. And probability of getting 4 is 1 out of 6. Now the question is, the probability of getting the sum of numbers to be 4 or 5. Sum to be 4 or 5 when both the dice are thrown together. So here the possibilities we can say, so 1 with 3 and 1 with 4 and 2 with 2 and 2 comma 3 and 3 with 1 and 3 comma 2 and 4 with 1. That's all. 1 2 3 4 5 6 7. Only these are the 7 possibilities we can get. Now we can see the probability, required probability, which is equal to, so we can say, so 1 comma 3, so we can get probability of getting 1 in the first die is 2 out of 6 into probability of getting 3 in the second die is 2 out of 6, or probability of getting 1 in the first die, that is 2 out of 6, and probability of getting 4 in the second die is 1 out of 6, or probability of getting 2 in the first die is 2 out of 6 and probability of getting 2 in the second die is 2 out of 6. And coming 2 comma 3, probability of getting 2 in the first die is 2 comma 2 upon 6 and probability of getting 3 in the second die is 2 upon 6, and probability of getting 3 comma 1, so 3 in the first die is 1 upon 6 and probability of getting 1 in the second dice is 1 upon 6, and probability of getting 3 in the first dice is 1 upon 6 and probability of getting 2 in the second dice is 2 upon 6, and probability of getting 4 in the first dice is 1 upon 6 and probability of getting 1 in the second dice is 1 upon 6. So here we can simplify. So 1 upon 36 is common, so 2 2s are 4 and here 2 1s are 2 and here 2 2s are 4 and 2 2s are 4 and 1 1s are 1, 1 2s are 2 and 1. So together we can say 4 plus 2 6, 6 plus 4 10, 14, 15, 17, 18. So 18 upon 36, which is equal to 1 upon 2. So we can go with an option C, 3. 1 upon 2 is the answer. Given a circle C, touch the line x minus y plus 1 equals to 0. Have the center on the positive x-axis. Let us consider a comma 0. So center of the circle C, a comma 0, and cut off a chord of length 4 upon root 3 along the line minus 3x plus 2y is equal to 1. So let us consider AB is the chord. So AB is equal to 4 upon root 13. And let R be the radius. Radius of the circle let us consider to be R. And there is a hyperbola x square upon alpha square minus y square upon beta square is equal to 1. And whose one of the foci is the center C. So that is alpha E, where E is the eccentricity, comma 0 is same as the center, that is A comma 0. And the length of transverse axis, so here we can say 2 times alpha, which is equal to the diameter of the circle C, that is 2r. So we can say alpha is equal to r. Now let us find the relation between the r and the lines. So we can say the perpendicular distance from the center upon the line x minus y plus 1 is equal to 0 will be the radius. So we can say the distance is, so a comma 0 is the point here, and the line x minus y plus 1 equals to 0. The perpendicular distance is the radius, and that can be given by a minus 0 plus 1 upon under root of 1 square plus minus 1 whole square, that is a plus 1 upon root 2. So you can apply the mod. Since we know that the perpendicular distance formula is ax1 plus by1 plus c upon root of a square plus b square is the perpendicular distance from point x1 comma y1 upon the line ax plus by plus c is equal to 0. And also the perpendicular distance from the point upon the chord, we can say, which bisects the chord. Let me consider this point is D, such that AD is equal to BD. So we can say the perpendicular distance CD is equal to from a comma 0 upon the line minus 3x plus 2y minus 1 equals to 0, or we can write minus 3x plus 3x minus 2y plus 1 equals to 0. So here we can write 3 into a minus 2 into 0, 0 plus 1 divided by under root of 3 square plus minus 2 whole square, that is 3a plus 1 mod upon under root of 9 plus 4 13. This is CD. And also we have the relation from the triangle CDB. From the triangle CDB we can say that CD square plus BD square is equal to BC square, that is R square. So CD square is nothing but 3a plus 1 by root 13 whole square, and BD square is nothing but half of the chord length. So BD is nothing but half of the chord length, that is AB, which is equal to 2 upon root 13. 4 by root 13 is AB length, so we can take 2 upon root 13. So BD square is nothing but 2 upon root 13 whole square, which is equal to R square. So here the radius is nothing but a plus 1 upon root 2 whole square. So let us simplify this. So we can get 9a square plus 1 plus 6a divided by 13 plus 4 upon 13, which is equal to a square plus 2a plus 1 upon 2, or we can write 9a square plus 6a plus 5 divided by 13 is equal to a square plus 2a plus 1 upon 2. Now let's simplify this. Cross multiplying, we will get 18a square plus 12a plus 10 is equal to 13a square plus 26a plus 13, or we can write 18 minus 13 is 5 times a square plus 12 minus 26, that is minus 14a, and 10 minus 13 is minus 3 is equal to 0. So we can write 5a square minus 15a plus a minus 3. So we can do factorization, 5a times of a minus 3 and again plus 1 times of a minus 3 is equal to 0. So we can write a minus 3 into 5a plus 1 is equal to 0. So we can write a is equal to 3 or a is equal to minus 1 by 5. Since the center is on the positive x-axis, so a cannot be negative. So this is not possible. So we can consider A is equal to 3. So that we can write alpha E is equal to 3. That is C is equal to 0. And focus we can consider with a small letter C. So C is equal to 3. And also now alpha is equal to R. So we can find the radius. The radius R is equal to mod of A plus 1 divided by root 2, which is equal to 3 plus 1 divided by root 2, which is 4 upon root 2. Since R is equal to 4 upon root 2, so we can consider alpha is equal to 4 upon root 2. And we have the relation alpha square plus beta square is equal to C square. That is 16 by 2 plus beta square is equal to 9. Or we can write beta square is equal to 9 minus 16 upon 2. That is 18 minus 6. That is 2 upon 2, which is equal to 1. So beta square is 1 and alpha is equal to 4 by root 2. We can write alpha square we can write 16 by 2, that is 8, and beta square is equal to 1, and hence we need to find 2 times of alpha square plus 3 times of beta square, which is equal to 2 times of alpha square is 8 and beta 3 times of beta square, that is 16 plus 3, which is equal to 19. So 19 is the answer